whether you understood the work or whether you didn't know what to do. Okay, nevertheless, let's move on.
Take it down.
I think the chairs are too big.
This is the assignment that I had given you. Use substitution method to solve the simultaneous equations. These were my two equations that I wanted you to solve. I told you the steps towards solving simultaneous equations by substitution method. You choose one equation which is simpler for you, and in that one equation you make either x or y the subject. For example, for me, I have chosen to use equation 1. Now, in this correction, I will only take you through one example. One correction, then I will leave the other one for you. In this example 2, in this question 2, which we are supposed to solve, I am saying let's use equation 1. And from equation 1, which is 3x plus 4y equal to 11, I want to make x the subject. How do I make x the subject here? I have to take this 4y across. And when any number crosses equal signs, you know it becomes a negative. That's why we have 3x equal to 11 minus 4y. If I want to make x the subject, then I divide by 3. Yeah, and that's what I am doing. The whole equation is being divided by 3 here, as you can see. So x is equal to 11 minus 4y out of 3. Now, if I had used equation 1 to get this value of x, to make x the subject, when I'm substituting, I'm supposed to substitute in equation 2. If I had used the equation 1 where I made x the subject, now I substitute this value of x in equation 2. What is equation 2? Equation 2 is 2x plus 3y, which is equal to 8. So where there is x, I'm going to put there the value of x here, which is 11 minus 4y. So I'll have 2 into, where there is x, I put 11 minus 4y divided by 3 plus 3y, and it is equal to 8. So what do I have to do? You will use the real mathematics of fractions now to get the value of y. Since this is a whole number and I'm multiplying by a fraction, you know when we are multiplying by a fraction, a whole number by a fraction, we will multiply the whole number only by the numerator. So when we multiply these two by the numerator, we open bracket, it becomes 22 minus 8, 4 times 2 minus 8y, then plus 3y is equal to 8. What do I do from here? I still have a fraction. How do I eliminate this fraction? I multiply everything by 3 such that this 3 can cancel. I'm going to multiply everything by 3 such that this 3 can cancel. And when I do that, when I multiply everything by 3, I will have 22 minus 8y times 3, and the 3 will cancel here to have 1 plus. I'm multiplying everything by 3. So this will also be 3y times 3, which is equal to 8 times 3. I think you can see that. And it gives me this 3, remember it cancelled. The essence of multiplying by 3 was to eliminate the fraction. So I now have 22 minus 8y, then plus this becomes 9y, this one here, equal to 24, 8 times 3. Now, when I collect like terms, this one from here up to here, negative 8y plus 9y, you agree with me that the answer is y. Negative 8y plus 9y. The answer is y. Then when I collect like terms, when this 22 crosses equal signs to find 24, it will become a negative. And that's how I end up having my y equal to 2. That's how I end up having my y equal to 2. Now, if I get y is equal to 2, I'm now free to substitute it in any equation of my choice. But for me, I've chosen to substitute in equation 1, which is 3x plus 4y equal to 11. 3x plus 4y equal to 11. And when I substitute, my equation 1 is this one. It means where there is y, I put 2. And this one will be 4 times 2, which is 8. Yeah, 4 times 2, which is 8. And when 8 crosses equal signs, it becomes a minus. 11 minus 8 is 3, and I divide by 3 to get 1. I divide by 3 to get 1. So, as we conclude this solving by substitution method, what do you have to note? Please, if you have two equations, choose one equation of your choice. Then in that one equation, you either make x or y the subject. For me, I decided to make x the subject here. By taking 4y the other side, it becomes a minus. Then I divide through by 3, and that's how I end up getting this as the value of x. But remember what is very important. If I had used the equation 1 to make x the subject, then this value of x, I must substitute it in equation 2. Don't take back this value of x in equation 1. It will give you 0. So if you have made x the subject in equation 1, make sure that you substitute in equation 2 here. Yes, you substitute in equation 2. And when you do that, you solve for y the way I have shown you. And when you get the value of y, you substitute it in any one equation to get the value of x. This work is very simple. I don't know why you are not doing my assignment, but I'm warning you, this should be the last time. I will not tell you to hand in the assignment again. I'm forwarding the names of those who have not been handing in to your parents, such that they see that you are wasting their money. Yeah? They are paying for you to be part of this holiday program, but you are not doing assignments, so you are wasting their money. In this equation 2, since I took you through equation 1, I think you can be able to do this part 3, which was the assignment also that you didn't do. Here, I have chosen to use equation 2. And from equation 2 this time, I've made y the subject. That means when 3 crosses equal signs, it will become a positive when 3x, and I have 3x minus 1, which is this one. Then I have 2y here, so I divide by 2 both sides, and y is 3x minus 1 out of 2. Then, since I used the equation 2 to get y, I now substitute it in equation 1. And what is equation 1? It is 4x plus 3y equals 24. So where there is y, I put there the value of x, which is I put there the value of y, which is 3x minus 1, and I solve using the knowledge of fractions. First open bracket, this is the whole number, and you multiply it by the numerator, it becomes 9x minus 3 out of 2, like that. Then multiply through by 2 to eliminate this fraction. These 2 cancelled here, and this becomes times 2, which is 8x. Then times 2, it becomes 48 across. When I collect like terms, 8x plus 9x, the answer is 17x. But when this 3 crosses equal signs, it becomes a positive, and 48 plus 3, it is 51. When I divide by 3, I get x as 3, and I substitute it in any one equation. For example, this one, I'm having 2y minus 3, of course x is 3, and that's how y ends up becoming 4. So please, and I want to assure you, if you don't have knowledge of a simultaneous equation, how to solve simultaneous equations, you are going to suffer until you stop studying. In senior 4, simultaneous equations there. Senior 5, simultaneous equations. Senior 6, everywhere. So use this chance to understand this work when you are still in senior 2. Now, today, I've prepared for you another method, solving simultaneous equations, but this time we are using the graphical method. And I have an example here. Pay attention, maximum attention, because you know after here there is assignment. If I have 2 equations here and the question is solved by using graphical method, in other words, we are going to solve it by using the graph. Now, what you do, you first obtain coordinates and you plot those coordinates. Then when you plot those coordinates for each equation, you are going to get 2 equations, you are going to get 2 lines. And where the 2 lines intersect, that will be the value of x and y. Let us look at how do we do this. For example, I have 2 equations. I want to form coordinates for this first equation. You know, any 2 points can form a straight line when you coordinate them and join them. Any 2 points can form a straight line. For example, we have x plus y equal to 5. From this equation, x plus y equal to 5, we are going to form 2 coordinates. How? We draw a table of x and y. You know, when you are plotting, you should have x and you should have y. So if you have xy, and you have this as your equation, we assume, or we like to use 0 because if I make, for example, x 0, it means I will remain with 0 plus y equal to 5 and y will be equal to 5. And that's exactly what I'm doing. For example, this is my equation. And I say when x is equal to 0, this is 0 here. When x is equal to 0, and I put this 0 where there is x, I remain with y, which is equal to 5. And that's how I get this first column. That's how I get that first column of my coordinates, 0 and 5. I'm forming coordinates for each equation. The first equation, I'm saying when x is equal to 0. When x is equal to 0 in this equation, look at that. No one should tell you to use 0 or what. It should be up to you. But you can even say let x equal to 1. When x is equal to 1, you will get y equal to 4. But the best one to use is 0. So I encourage you, let's all use 0. Let's all use 0. When x is 0, the value of y is going to be equal to 5. And now after getting the value of y, when I use the x is equal to 0, I can now use y again also to be 0. So when y is equal to 0 in this equation, I will only remain with x, and x will be equal to 5. And that's how I can form my coordinates from that equation. I want to repeat this. You have two equations which you want to solve by using graphical method. Get each equation and form any two coordinates. For example, I'm beginning with this. I first draw my table of x and y. Only 2 points are enough for you to form a table. When x is equal to 0, begin by making x 0. When x is equal to 0, that's what I'm writing here. When x is equal to 0, I put here 0 and y will be equal to 5, and that's why I'm having 0, 5. 0 for x and 5 for y. And when, now after making x 0, in the next step I will make y 0. When y is equal to 0, even x will be equal to 5 because y is 0 here. So I remain with x which is equal to 5. And that's how I get the coordinate as 5, 0. That's how I get the coordinate as 5, 0. Take note of that. So for the first equation, I have its two coordinates, which are xy is 0, 5 and 5, 0. I now go to the second coordinate, to the second line. My second line is 3x, I mean 2x plus y equal to 6, which is this one here. So 2x plus y is equal to 6. I draw my table again for x and y. Now, I begin by making x 0. When x is equal to 0, it will be 2 times 0, which is 0, plus y. So y will be equal to 6. Because x is 0, 2 times 0 is 0. So y is equal to what? To 6. Now, when I made x 0, in the next step I say, what about when y is equal to 0? What will be the value of x? When y is 0, this one becomes 0, where my pointer is, and I remain with 2x equal to 6. I divide by 2, and I have x equal to what? To 3. So when y is 0, my x is equal to 3. So my coordinates are 0, 6 and 0, 5. Okay, these are the coordinates for the first equation. These are the coordinates for the second equation. Before I take you to the graph, I want to, is there any person who is having a question here, is not understanding how we are getting the coordinates, because it is important before we look at the graph? Is there anyone question?
No.
Anyone question?
Where do you get the 3 from?
Where did we get the 3 from? Thank you. We are saying, in the first case, we said that when x is equal to 0, this one becomes 0 and y is equal to 6. This one is okay. You should be understanding this. Then in the second case, we are saying when y is equal to 0. When y is equal to 0 in the equation, when y is equal to 0, it means I will only remain with 2x equal to 6. So 2x equal to 6, I divide by 2, and x is equal to 3. So x is 3 when y is equal to 0. That's how I'm getting that coordinate. I think I've answered you. Another question? Feel free, please. Can I now take you to the graph? Since there is no question, let's go to the graph. So, having obtained our 2 points, we can now take them to the graph. And this is my graph that I have plotted. my first equation was x plus, my first equation was x plus 5. I mean x plus y equal to 5. And we got its coordinates as 0, 5 and 5, 0. So, you know, the scale that I'm using here is from here up to here. These are 2 centimeters. So I'm using 2 centimeters to represent 1 unit. Yeah? So if these are 2 centimeters, it means that each small square you get, because the small squares are 10, you get 10, okay, you get 1 and you divide by 10 and you get 0.1. That means each small square is 0.1. So this is 0.1, 0.2, 0.3, 0.4, 0.5 here, halfway, 0.6, 0.7, 0.8, 0.9, 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2, 2.1, like that. So my coordinates are 0, 5. I begin with 0 on x-axis, 0, 5. That means we begin with the x-axis. 0, 5. This is my coordinate. And the other coordinate was 5, 0. I think you can see this. Yeah? 0, 5 and 5, 0. So I plot my coordinate. My coordinates 0, 5 is this one and 5, 0 is this one. Now I join them together using a ruler. I form a straight line and I label my line as x plus y equal to 5. Then I now go to my second line. What are its coordinates? Its coordinates are 0, 6 and 3, 0. Here I go. 0, 6 is this one and 3, 0 is this one. So I join using a straight, I'm using a ruler to form a straight line, and I label my graph also as, 2x plus y equal to 6. Though I forgot to label it here, but it is 2x plus y equal to 6. Now I get where those two lines are meeting, their point of intersection. These two lines. For example, here, if I ask you to read this coordinate, on x-axis it is 1, so that means the value of x is 1. And on the y-axis it is 4, that means the value of y is 4. That's where the lines are meeting. So without wasting time, the point of intersection is 1, 4, meaning 1 is on x-axis, so x is 4 and y is equal to, x is 1 and y is equal to 4 on the y-axis. So y is equal to what? 4. That's why I'm saying, therefore, point of intersection is 1, 4. And the coordinate is xy, meaning x is 1 and y is equal to 4. That's how we solve simultaneous equations by using graphical method. And as usual, I have 2 equations for you, which you are going to do for me using graphical method. If there are any questions, at the time remaining, I want you to ask a question if it is there. I don't want you to have an excuse for not handing in the work. Any question?
Teacher, should we do the work in the graph book?